Morning, everyone. Welcome to the May OCP Server Project meeting. I'm going to go ahead and get started. As people join, we do have a full agenda today, so I don't want to lose any time. Start off with announcements. We did have the EMA Summit a couple of weeks ago, and all the decks and recordings are posted on the website under past events. So encourage those who weren't able to join to go and peruse some of the presentations and the videos that were presented there. Upcoming, we do have the APEC Summit August 5th and 6th in Taipei City, and of course the Global Summit coming up in October. Seems like we just have back-to-back summits these days at OCP. It's a good sign. We're continuing to grow. OCP Foundation and Steering Committee. I haven't looked. Do we have Greg online yet? Yeah, Greg, do you have any updates?
No update, maybe just to mention that the Open Systems for AI initiative work continues. There was a couple of sessions, 3 sessions, I guess, about kind of data center level talks and direction that were held over the last month. And then I think we're aiming maybe end of June to have an IT infrastructure set of meetings. So kind of just be on the lookout for that. There'll be some information coming up in the next couple of weeks.
Yeah, actually, hopefully in the next couple of days, we're trying to get this set up for June before all the summer stuff starts with July. So will be sending out a call for papers for that, hopefully in the next couple of days. So look for that and send back a response if you want to participate in that.
Yep, that was it for me, Jen.
Okay.
This is Alicia. I just wanted to mention that the call for proposals for a global summit, the deadline for that is June 16th. So I just wanted to make sure that everybody is aware of that deadline. And I can drop the link for the call for proposals page in the chat for anybody who's interested.
Oh, I didn't realize we already had that open.
Yep, they sent out, I think last week, the announcement, and then another reminder just went out just this morning.
Okay. Yeah, thank you. First up, we have OCP sub-project with Damien.
Thanks, John. Let me share my screen.
All right.
Okay. Screen 1. Okay, cool. So yeah, here's update from the OCP NIC for the month of May. It's a couple items to cover. So first of all, that we are accepted into the contribution database. Steering committee have approved it. So we are our version 1.6 is actually in the database, contribution database. The second up is actually on when we have all the mechanical and electrical definition of TSFF. We actually it says my internet connection is unstable. Can you hear me?
Yeah, we can hear you fine so far.
Okay, cool. Yeah, and then yeah, we lack of a thermal modeling in there. So currently it has been complete, and we just need to update into the spec. So yeah, this is for the thermal areas. And next, we have been attempting to further increase the thermal headroom of the OCP NIC. So the thermal workstream have looked into extra tall form factor, which is something we sort of investigate together in the past with the tall form factor. Earlier, when we investigated, we called EET SFF. The extra is based on a slightly taller than the tall, which I think is 20 point something millimeter. So that we looked into that, but now the extra tall is actually like 30-ish millimeter, and then intend to fit into 1U chassis using the full space. So we do see some value, of course, the heatsink get taller, better cooling, and then when we compare the equivalent, the PCIe CAM card, which is the dual slot, then the performance are similar in terms of what we can see here. There are further feedback from the PCIe MHS group when Joe went there and present, which unfortunately that day I was sick. And then there are actually some feedback from we should compare it against the single slot as well. So the single slot low profile half length and single slot full height half length are something that we get feedback from PCIe MHS side to understand how this fare against those. But I think the biggest thing we want to get feedback from the server group here and the team here is mainly this, whether this particular will offer a long-term benefit to the servers. Because as we all know, like one more form factor is yet again another form factor the server, the chassis system designer will choose. So while it has benefit to thermal, we would like to get feedback from the group here to see whether we see value from this. This is more like an update that we are studying it, not necessarily we are doing it. It's more like we are studying it. And another the same thermal work stream also working on liquid cooling stuff. In fact, tomorrow there are some liquid cooling discussion. If folks are interested in this area, yeah, do let myself and Joe know. So yeah, the intent is see how can we increase OCP NIC thermal headroom. Okay, the next up will be on the DCFF SI update. So the test fixture is back, and then there are some issue being found by Intel. So in the next slide, you will see, yeah, by jumping a clock, then the test board is working. But that said, the final version will actually spin the board by Dell before we share it to more public. One thing I get email question is, hey, we do have the DSFF Gen 6, the CBB SI test fixture. Where is the CLB? Yeah, one thing is like when I get checked with Dell and the team, seems like previously when we say the Gen 5 test fixture, it actually able to support Gen 6 as well. So the from the CLB perspective, that is actually ready and shared in the wiki. So for those looking for the Gen 6 CLB, we actually have it available. And here is the wire that was reworked, that was missing. And then after doing this, the CLB was working. Next part is the thermal test fixture. So basically the test fixture have arrived and been tested. So yeah, there's one SM bus that was miswired. Other than that, the testing is still ongoing. And last but not least is we are looking into the NIC ecosystem and see what kind of form factors available for use as NIC today. So within OCP, we have 3. So the APAC, SFF, DSFF is our OCP so-called definitions. PCI CAM, of course, is PCI 6, and PMM is from SNIA. So we look at some of the use case of NIC, and we are currently looking at like the first and second use case. OCP NIC do pretty well on using the SFF, and then the smart NIC use case we are trying with our DSFF, which is the double. However, OCP NIC seems to have a bit of setback into whether that is the right form factor for the very high speed NIC and high density. And we are looking this in the lens of industry form factor as well. Not only that, hey, it's the OCP NIC. Do we need to create a form factor that is based on OCP NIC, that to handle this, not really. We are looking into all. That said, we are kickstarting a work stream to evaluate to see whether we need another form factor to handle this use case. I think based on some conversation with different industry player, the use case exists. But currently, it's just that whether this is being done in an open manner or different companies have their own proprietary form factors. So yeah, we are working on this area from OCP NIC perspective. And yeah, once we have more alignment, we can bring back to the server project for updates. So that is what we have for the last month.
Yeah, I'll definitely be interested to see, there's definitely a need for some high-speed NICs, but it isn't the volume that we have with the others, and we are starting to proliferate the OCP NIC, so be interesting to see what that work stream comes back with.
Yep.
Anyone have any questions or comments for Damien? All right.
Okay, back
Thank
to
you,
you,
Damien.
John.
Next up, we have the MHS update. Let Brian give an intro, but we also have contribution updates for 6 different specs. So it'll be a lightning round of different specs coming through. Brian, are you sharing?
Yeah, can you see my desktop, John?
Yep, we can see it.
Okay, so first I'll give an update on the last public meeting, and then I'll give an update on the specs. Is that agreeable, John?
Yeah.
Okay. So last month, this is posted to our wiki, by the way, if you want to go review these slides or the audio. Last month was relatively light for us because we had the regional summit just prior to the meeting, but we did have an update from the MHPM work group and the Edge MHS work group that I'll go through. For those that did miss the regional summit or could not attend, I did post our presentation and slides to the MHS wiki. So we had 4 different tracks at regional summit. They covered what's new in our PNP work group, the DCSCM 2.2 and 3.0 work stream, as well as what's new in MHS and a track on DCSCM Open Boot and Management Framework. So if you want to go review any of those, if they sound interesting, there's a link on the wiki. This is a slide that I'll be talking about. We basically have a bunch of maintenance updates to some of the specifications that we contributed back in 2022. This was based mainly around feedback from the community, as well as some new features that we wanted to introduce, for example, the DSFF NIC that Damien just talked about. So I have a set of slides on this I'll go through. For the SDNO, Mike is going to talk about some of this when we go through the what's new slides, but our 1.1 spec is a rather big update that was finally just published, as well as the MCAD files for that spec. Basically, the 3 biggest updates for that spec was the addition of 48 volt for the HPMs. We added support for a new DCSCM form factor called compact form factor. It's a vertical 1U, can also be used horizontally if you want, but much smaller, more dense design. And then we added a new class E that enables direct plug of MCRPS power supplies into the SDNO HPMs. If you're interested in hearing more about that, you can go watch that video. It's on the wiki, as well as the new specification and MCAD. Dirk gave an update on our new Edge MHS HPM specification. Highlights included around July, we want to have the first version, the Rev 0.5 as we're calling it, available on the wiki for the public. And then similar to the other MHS specifications, we hope to have a 0.9 available around Global Summit with a 1.0 by the end of the year. And some of the biggest, I think, items that they're currently debating is riser placement on the dense form factors required by Edge. So they're asking for feedback. Again, more details in that call if you want to listen to that presentation. Any questions? Okay, if not, I'll go through the other presentation. I don't think I have all the work stream leads on, so I'll try and cover if any of them are missing. As I was showing on the previous slide, we want to update the contribution database with the latest base specifications. So for MHS, anytime we have a new base specification that the work group approves, it's posted on our wiki. But because of the process required to get that into the contribution database, the contribution database is often behind the wiki. And so the idea here is we want to sync them up. You can see we're sending 6 specifications through that process. That includes reviews by the incubation committee, and then those get pushed into the contribution database. So I won't go through, the mission, the hierarchy, and the tenants. That's more for the incubation committee. We'll just jump straight into the updates. So Mike, I think Corey's missing, so I'll cover the first one for him. For FLW, this is our full width specification. 1.0 was released back in 2022 into the contribution database. Today, there is a 1.2 RC3 that's available on the MHS wiki. So the biggest changes in going from 1.0 to 1.2 was around the additional support for the DSFF NIC. We always had supported 2 SFF NICs on full width, but not specifically the DSFF. And so the new specs talk about how that NIC is supported. It talks about what happens when you don't utilize all the lanes on the NIC, and what to do with things like NCSI. So and then the other big change was the LFF NIC was deprecated to the supplemental information of the spec due to the fact that the OCP NIC team had also deprecated that NIC as well. The other thing on full width that was we got a lot of feedback on was the location of our power egress connectors. And so we converted to recommended locations with flexible zones. So you can see a picture here of, instead of a fixed placement, they now have zones around them where you can move them around in these zones and create more flexibility for processors and VRs that want to live close to these parts. There's other minor changes in the specs around more flexibility. So I encourage you to go take a look at full width spec in this section on the versions. We talk about all the details, but most of them are just adding more clarity and giving more flexibility. Mike, you want to go through Estino?
Sure. So Estino, obviously the 1.0 was a little newer. but we still had, as Brian alluded to earlier, three kind of significant changes that we made with the 1.1. So the first one was support for 48-volt power ingress and egress. This is aligned to MPIC 1.1. I think Cliff will mention that in a moment. At the highest level, it's a consistent architecture approach with 12 volts. There are some protections in place like color coding and such to avoid 12 volt, 48 volt incompatibility or misplugs. And otherwise, the differences are relatively minimal. We added support for the compact form factor. Brian mentioned that. The approach here was very unconstrained, given that this is a very flexible form factor in terms of where it can be placed and its usage model, and it's somewhat new, so we don't want to stifle system layouts. We're curious to see how people use it. So we provided a recommended placement zone, but it is not a required location, and we can update that if we see other interesting uses in the future. But we did want to have a recommendation to drive consistency and be consistent, not just in the industry, but across the different board classes. And then the final thing was that we added a new HPM class, Class E. This was previously called Class C with direct plug power supplies. We decided ultimately it was easier to distinguish between the two different HPMs by giving it just a different HPM class letter. So this is a 19-inch full wide, similar to a Class C, shares consistent holes and risers and things with all the other ABC boards, but it allows you to direct plug CRPS if you, so this is somewhat of a different system layout than with a PDB like the other HPM classes. And we do talk in the spec about where this might be more interesting to use and where something like a Class C might be more interesting to use. So I think those are the major updates for SDNO, and then DNO is a little different in that if you look at 1.0 to 1.1, 1.1's been out for quite a while. The change bar version of the document has a ton of changes, but there isn't a lot substantive. The major substantive change was that we completed the type 3 definition. That was the half width 19-inch, kind of intended for a 2-socket shadowed layout. In 1.0, this was a TBD length, and we updated it in 1.1 to finally kind of close it out with 555. This was to align with what the SDNO spec was doing. And then the reason I said there's a lot of changes, but many are not substantive, is that, you know, when we did SDNO, it was kind of our second generation HPM spec. We rewrote a lot of sections, tried to clear up a lot of things that were confusing based on feedback. So we backported all of those clarifications and explanations into the original DNO spec as well. So a lot of changes, but fundamentally from a requirements perspective, not a lot. The major thing was the type 3, and then some things around the board thickness. I think that's it for DNO.
Okay, Cliff, are you on?
Yes, I am.
Okay, why don't you go through MPIC?
Sure. So we previously had, in the original release, we had focused only on 12 volt content, and we noted that we wanted to add 48 volt later. So this update does that. It includes, basically it leverages the pinout organization and the connector envelopes, but it defines 3 new connectors. It defines a dedicated supply connector, which was the one Mike was showing on his slide, where it expects a non-ramp controlled voltage, input voltage, to be compatible with 48 volt racks and other equivalent sources. And then for the peripherals, it uses a form factor with the same envelope as the existing PIC power, 12 volt PIC power, 2x6 and 2x12 connectors. But as Mike mentioned, it includes new keying, and all the new connector those two connector groupings are color coded to prevent misplug. The third connector that is added is an updated PDB connector, because with the 48-volt architecture, the PDB now the configurations with the PDB for 48-volt would not be powering the HPM through the PIC power connectors, and therefore additional signals were needed in the PDB management connector. So in summary, the spec defines those new connectors. The supply connector is more unidirectional, and same with the PIC power connector. But a lot of the remaining things are similar to the existing 12-volt MPIC approach. So you want to pop to the next slide. Okay, so on this one, I added a bunch of details here, more for feedback, or not for feedback, for information, but there were a lot of updates in the 12-volt section as well. So we did a bunch of made a bunch of clarifications and a bunch of fixes, but the main things that were larger or more substantial were around enabling the cabled boot to use power disk functionality instead of requiring the HPM to include the gating on the HPM. And we also added or converted the RFU on the PDB so that there was a method to power cycle the entire standby subsystem of the system without having to physically plug and unplug the system. And then we added some recommendations. This most important one was related to the update we made to the PIC power mating sequence to ensure that it's possible to prevent loading the PIC power connectors until mating sequence has completed. So that is more of a safety item to ensure connector current rating are maintained when the load is enabled. So I think that's all for,
All right, yeah, thanks,
Yeah.
Cliff. Javier, are you online?
Yep, I'm here, Brian.
You want to go through the MXIO?
Sure. So on MXIO, we have some minor updates there. On the pre-triaux management pin, we clarified some rules on how that should be used. This is an optional pin meant to power a room with really limited power consumption. So that was added. We added the specification compliance to be aligned with all these images specifications. We added cable expectation on SFFT8 and 16 connectors so we can improve the compatibility. And this is aligned with the copper link signal specification that the SIG is following. So we wanted to have better interoperability between both consortiums. And lastly, we added or updated the pull-up values on some of the Flex IO signals, which previously were 127Ks to 100Ks, to have slightly better performance on that pin.
Okay, fairly light updates on XIO, right?
Yeah, XIO was pretty light. On the MPST though, we had several changes or updates. I pocketed them into 3 different categories: the editorial update, which is mostly typos and clarifications that are not related to any functional change in the spec. We had some electrical update. We tightened up the tolerance for the baud accuracy. We revised the source to destination discovery method, which was a huge addition into the specification. It's only 1 chapter, but it has a lot of clarity and visibility into what the specification is and how it should be implemented. Aligned with the XIO specification and some other minor details there on trying to be consistent with the XIO specification. And then there were some logical updates to the specification. All of this is on the protocol side. I don't think I should go through all of them, Brian, but it's here for people to review.
And wasn't there some additional alignment with PCI SIG based specifications?
Correct. All of those are aligned to that.
Okay.
Yes.
So I think PCI SIG based specification came out before MPST, and so there was just some alignment necessarily at the end.
Correct.
So that's all I have, John. In a nutshell, that's what we'll be presenting to the incubation committee in the next meeting. Any questions for the leads?
On the cabling and basically signal integrity, getting ready for PCIe 6.0, 7.0 bit rates. Are there challenges? Are we going to meet requirements? Is modularity creating any new problems that we need to solve?
My understanding is that PCI SIG is updating the copper link specification to include Gen 7. There's minor updates for the total budget, but other than that, it's compatible.
Okay, so the connector and cabling and
The same.
MIO that we have is compatible. It will.
Yeah, the only difference is the total budget. Javier, do you want to add?
Yeah, I just want to add that the connector is being revised also, right? So it's going to be footprint compatible, but there are new connectors coming to optimize on the PCI 6 signal integrity
For
performance.
crosstalk, right?
For crosstalk, yeah. And also on the cable, right? The cable is being redefined by different vendors. But overall, the specifications and the budgets still apply, and we don't foresee a change, at least on the pinout or anything drastic on XIO specification.
Very good. So when you said the connector is going to be updated, did you mean the PCIe chem slot connector, or did you mean the
oh no, the
XIO?
SF58 and 16.
Okay.
Also the PCI chem is being updated, right? But for the sake of this conversation on XIO specification, we are proposing to support both SFF-DA 1016, SFF-DA 1033, and those connectors are being slightly updated on the internal pin mechanical structure to support PCI Gen 6.
Okay, and then to eliminate the need for cables, as we discussed a long time ago, adding cards could plug directly into XIO, MSI, MCIO connectors.
On 1033, right? That's the addition on 1033 on XIO. So it's a slightly different connector on than MCIO that allows to put the cartridge riser there.
Right. Is there any activity in enabling or standardizing add-in boards that directly plug into HBM?
And not as of today, no.
Okay. Thanks.
All right. Thanks, everyone. This deck is available on the server wiki, and all these draft specs are available on the MHS wiki. These will go to the incubator, the committee, and should be on the contribution portal in a couple of weeks, but that always takes longer than it should. All right. Next up, we have the AI hardware software co-design subproject with Jack Harwood. Jack?
I'll just do a quick, in the interest of time, John, I'll do a quick verbal update.
Okay.
So we did an update for the Open Systems for AI, talking about the project, where we are, and the work that we're doing in terms of that. And we shared the deck out, so everybody had that, and I'll share that deck out with this team. We're in the process of driving white papers around AI fabrics with respect to topology, scale up, scale out, edge algorithms, and then storage data services. And so we're mapping that into a simulation modeling space for us to not only produce the white paper, but also validate the data that we include in the white paper. And so with the slides I send, you'll get to see that. And so, John, as I sent you an email this morning, we'll coordinate on kind of the call to proposals for OCP Global Summit to make sure we're kind of in sync in terms of some things we're doing. But we're meeting on Friday to talk with the group. And, we're connecting across HPC, AI topologies, as well as edge algorithms, and then some compute models that are emerging. So there's a group very interested in neuromorphic computing. And so we're trying to see how that fits, what algorithms, where some pieces are. But our goal in the end is really just to identify swim lanes in the AI space, and then how do we actually do some modeling to validate the assumptions that we make. That's it.
Thank you, Jack. Anybody have any questions on AI software hardware co-design? All right. Next up, we have Alan on HPC. Are you on verbal, or you want to share?
Just on verbal, nothing major from me. A couple of things. Those of you that have been following us, so we did apply for some grant funding from the New Frontiers project from the DOE, Oak Ridge National Labs. That's been that was supposed to be awarded in February, but it's been ongoingly delayed. So we've just been notified that the delay is still ongoing for maybe up to another 120 days with no guarantees. But we've not been thrown out of the running for funding, so keep our fingers crossed on that one. The only other thing we've started to look at is now we've seen some new direction from where NVIDIA are going with their Vera Rubin architectures, and seeing the full liquid-cooled blades and the huge complexity of that. Just revisiting the way what our sort of ideas over the last 4 years, and seeing if that changes our approach. So just digging in again. But no real progress at the moment, just exploring options. That's it from me.
All right. Thank you, Alan. Anyone have any questions on HPC? Okay. I don't believe we have a CMS update, unless anybody speaks up that has an update I don't know about. All right. Next, we have Jawad on Open Chiplet Economy, and he'll hand it over to Jeff for a universal DDD link layer. Jawad?
Yes, hi, John. Can I share one pager?
Yes.
Okay, so today we have a approval request, so I'll reserve most of the time for that. But overall, it's been a busy summer schedule for us. We have, as you all know, due to all the interest in AI on the semiconductor and chip side, there's a lot of talk about interoperability of dies and coming from various vendors. So one big challenge in all of our work streams is how do we make these things interoperate? So, and more historically, we've done a lot of work on die-to-die, chiplet-to-chiplet interfaces. And now our major work streams, including chiplet systems, modularity, design exchange, business, and reference design work streams, all of them are focused on the interop at a higher level, and Anu and myself are usually involved in making sure everybody is working in sync on these concepts. And the approval request that you will see today is one dot along that path, which is to come up with a universal transaction link layer for die-to-die PHYs, and Jeff will go through it. We are pleased that the work stream and Montana Micro has made significant contributions in the past and continue to do that. In addition, we are setting up a day-long event in Taiwan for the regional summit in Taiwan, and so far the interest is pretty strong. And we do have a tentative full-day agenda for a open chiplet economy show. So we'll be finalizing that in next couple of weeks. There's some notable industry speakers from Taiwan who will be joining that one. Due to a lot of requests from industry, we are doing a version 2 of our die-to-die PHY metrics workshop. It will be on July 11th, right after a conference on chiplets called ChipCon in Santa Clara, and this will be hosted by Carnegie Mellon University. We also, some of our work streams are presenting at local conferences. There will be a presentation at Design Automation Conference, and there will be a presentation at ChipCon as well, and those are all invited talks. So with that, I will hand it over to Jeff from Montana Micro. Jeff is a co-lead of our link layer work stream, so he will give you an overview of the approval requests. Jeff, all yours.
Okay. I think I need you to stop sharing, and there we go. Share. So thank you so much for the opportunity to show our proposal, our proposed contribution to make the link layer, the transaction link layer specification, more of a universal specification where we will offer a binding to UCIe. So in terms of what's going on in the market in terms of interoperability, the problem statement that we have here is that there seems to be a lack of multi-vendor chiplet interfacing protocol standards. UCIe, it is limited to PCIe, CXL, which are higher latency, not super well suited for, I think, chiplet integration or disaggregated integrations. Or it offers a streaming protocol that's really not specific to the logical protocols that the chiplets functionality is actually speaking. The AMBA chai chip-to-chip standard has been introduced into the market. However, this really kind of forces expensive chai protocol bridges if you're not using CHI in the integration, chiplet integration, or adopt pretty expensive NOCs, or it's the binding is limited to a UCIe FDI 256-bit low latency flip format. And this format imposes a CRC retry mechanism, and which our link layer that we contributed, uses a forward error correction scheme. The other aspect here is that there's a lack of link layer portability across various PHY layers. So UCIe specification, it has its own physical layer, right? And then the current transaction link layer specification is limited to BOW. So the solution that we're proposing here is a universal OCP, OCE. I mean, we introduced these specifications back when it was called Open Domain Specific Acceleration Project. So now offering it in open chiplet economy. What we're proposing here to contribute is a binding of the TLL to the UCIe FDI layer, and we're using the raw streaming format, which allows us to go ahead and have the forward error correction ECC active on the link. In addition to that, the original contribution we made back in 2023 was this idea of being able to bind any kind of protocol to the TLP, or the transaction link packet format. And so you can, rather than it being, forcing a CHI protocol, you could support CHI for fully coherent, or ACE Lite for IO coherent, or just AXI if you have, like, let's say, a non-coherent accelerator that on a chiplet that you want to interface to the system. And so bringing this into the OCE community, it uniquely enables the community to define these chiplet interoperabilities using AMBA-based, and it's not limited to AMBA, but AMBA-based protocols that have been used for IP integrations and monolithic SoCs. So introducing those, or allowing those protocols to be packetized over the length, the chiplet lengths, makes the chiplet integration look just like an IP integration in an SoC. Okay, so I'm actually formatting our contribution into the template, and I saw that there's a base specification, design specification, product specification. So I was trying to break this into those layers. So we can start with the base specification here in the TLL. That's what we contributed back in 2023. This is the ability to have this transaction protocol format or packet format that we can bind to. In that specification, we also have some, TLP messages, like virtual wires or messaging, or different types of, these are protocols, but they're actually part of the TLL specification. But then we have protocol variants. In our case, we have CHI.E and an AXI5 Lite protocol variant. And this is a way of mapping those protocols to the TLP formats. And then on top of that, we also contributed our Veyron V1 profile, chiplet profile, which takes multiple variants and creates a profile for the chiplet. And all of these protocols can concurrently communicate over this chiplet link. And so what we're proposing here is, while the original specification was tied to BOW, we're offering this binding to UCIe FDI layer. And then we also want to encourage the community and attract interest in the community to help define these profile variants and profile classes. You could think about them as being general compute or AI compute, those different classes that we can generalize and create interoperability around. So in terms of kind of the objectives of OCP, openness, this community-driven approach will create interoperability, which can map any protocol, any desired protocols to any PHY transport. And we have, with this specification, really market-leading ultra-low latency. Our focus, since we are a server class CPU, latency is super important for us. So we've really optimized this specification for low latency and low overhead, and also robust with the forward error correction capabilities. The impact of this proposal is really adopting UCIe, really capitalizes on the recent market traction that they've had, and offers a flexible protocol binding scheme, which doesn't exist in the UCIe world right now. The technology is really scalable from very cost-effective to very high-performance integrations. And its sustainability really given that it's a flexible mapping, we're quite adaptable to new protocols or PHY technologies that become important for each market segment. So we're quite active in automotive, and this is a push in automotive to be able to standardize this kind of interfacing. In terms of the contribution timeline, so we made the original contribution in 2023 with the TLL spec and also some variants and profiles. There were other people that contributed to the variants and profiles as well, other companies. So we've got a starting database on that, but we want to expand it. As you heard, the 2.0 spec is adding a sideband or control capabilities. Ventana really wasn't involved with that contribution. And then this new contribution is coming up with the universal transaction and link layer capabilities binding to UCIe. And then also just to work within the community to really encourage participation and help build an interoperable OCP chiplet marketplace. So that was all the slides I had to present the proposal. I'll just wait and open it for any questions.
Jeff, which companies are co-contributing this work?
This binding to UCIe is just contributed by Ventana. Brian Murray from VeriSilicon is helping out with the specification and also maybe other alternative bindings to UCIe flip formats.
And do you anticipate any impact to other specs such as UCIe? Do they need to accommodate what you're proposing here?
No. So the scope of the contribution really stops at the UCIe standard specification. So we're just using an available raw format that the UCIe PHYs have to implement. So there's a high probability that all third-party UCIe PHYs will work with this specification.
Okay, thanks.
Mm-hmm.
All right, thank you, Jeff.
Okay.
All right, moving on to work streams, the external PCI connectivity. Mohammed, do you have an update this week or this month?
The team is not meeting weekly at this stage because we did release the requirements, but I can give you updates on samples that we've started testing and validating in terms of cables, optical meetings that we've had at OFC. I don't have any slides, but I can tell you that the industry is aware of the need of extending the PCIe connectivity for both CXL and NVMe storage, both for NVMe HDD, which is gaining momentum now in terms of PCIe direct connectivity to JBODs that are NVMe based and PCI connected, as well as for CXL, pooled memory or shared memory in the near future, as some momentum is being picked up around AI benefits of shared memory. So all that is just kind of gaining momentum with the PCI SIG, OWG, and EWG to reinforce the solidification of the form factors, for optical plugs and connectors and cables, and the initial work on the SIG side for OWG required retimers. There's a push now to do the linear non-retimer based optical to reduce cost and power. So there's a lot of effort in different areas, but not really run under the OCP umbrella at this point. It's kind of an industry picked up our requirements and they're moving forward.
Right. Well, that was the whole design. Our whole purpose here was to get the industry moving, not for OCP to come up with any competing specs.
Correct. Yeah, we wanted the experts to go out and do the right things for us and align it with their Ethernet volumes.
All right, thank you. On open system for AI, as Greg stated earlier, we've done 3 hardware, not work streams, hardware tech days. And we have the infrastructure one coming up. You should see a call to papers for that coming out in the next week. So look forward to that. That brings us to our last thing on the agenda. We're trying to increase the inter-project communication and the cooling subproject with the immersion cooling with Rolf Brink. He's trying to join what he's doing, what we're doing in Server Project. So I want to give Rolf a few minutes to talk.
Sure, thanks. Sharing my screen at the moment as well. I just want to flash a couple of slides to provide a little bit of background. We've reached out to John to start an interaction around how we can effectively work together between the immersion project and the server project, because there is some overlapping work that is being done. And to explain this, I just want to very briefly touch upon something that we've implemented within the immersion project. Immersion project is one of the biggest projects right now in OCP, and therefore the traditional project structure didn't really work out for us anymore. So we've established a whole different governance structure with our community, and we've divided the community up into 4 pillars, which are technical committees in our case. One is focused on fluids, one is on solutions, one is on reliability, and one is on IT equipment. And in particular, the reliability and IT equipment committees, they are overseeing some work streams. The people who are leading these committees are Samantha Yates from Intel and Brian Kincaid. They're chairing the reliability committee, and the IT equipment committee is currently chaired by Austin Hypes from Unicom. And the work streams that are overseeing for IT equipment is advanced cooling techniques, which is where, sorry for some of the unreadable text here, can't fix it right now, but advanced cooling technologies is looking into new ways of implementing precision cooling or more advanced cooling methods within the immersion ecosystem. Design guidelines for IT equipment is where we're focusing on how to optimize IT equipment for the purpose of immersion. The signal integrity workstream is focusing explicitly on signal integrity challenges across IT equipment design in combination with the dielectric fluids and the different dielectric constants in these fluids. And the reliability group is very much focused on what defines reliability from both a material point of view and also components level, but they're also looking at the thermochemical reliability aspect. So what really makes something reliable, and how do we help advance the ecosystem with the progression of the adoption of IT equipment, in particular in immersion. So I'm going to skip over these slides for time concerns. So really, what are we looking at this point in time, where a lot of these work streams are advancing fairly quickly, but one of the limitations of our current project makeup is that we have a lot of fluid manufacturers, fluid vendors. We have a lot of system integrators that are involved, but we don't have so many server designers or component designers in our ecosystem. And that's where some of these work streams, and these are the work streams I just showed, are just a small handful out of a much larger pool of work streams that we're currently overseeing. These work streams in particular, they're currently lacking some of the server manufacturer and server design expertise. So instead of going out into the community and drawing more audience in, we figured it would be much more beneficial to ensure that we have some harmonization with the server project, where a lot of the server design aspects are being discussed. So some of the topics that we're aiming to discuss with John first, before we really bring this into this community, is how can we ensure that we can get some involvement of some of the expertise that we're lacking, and what is the best way of work to ensure that we're aligned with the server project. And there's probably a bunch more questions that we want to be raising. How can we effectively collaborate on some of these aspects? To give you an example, one of the goals that we have is that we can come up with a way to to mark a server system as immersion ready. What does that mean? What do you need to qualify against when you want to state that something is immersion ready? Immersion is coming at us really fast, and these are critical work streams that will help with the progression of the immersion ecosystem. But it is not really viable to progress that without some level of interaction with the server community and this community, so that this community where all the design knowledge exists within OCP. So we don't want to set up a parallel. We want to make sure that we can utilize the existing structures within OCP that are there. That's pretty much it, John. I guess that's. I hope that is sufficient to get to start the conversations in the upcoming weeks. You're muted, John.
Yeah, so we need to see which OCP server projects work the best. I know MHS is probably one of the big ones as we define the different components. Are there any changes or tweaks to any of those specs to help harmonize with the immersion cooling? And what other sub projects we have in server that might want to work closer with? We don't have a large server design community just sitting out here. It's almost everything we do is done inside our sub projects. So we probably need to work on identifying how to coordinate inside those sub projects.
Exactly, and that's really what we're going to be focused on, right? To identify, hey, what is the best way to leverage or respective projects' capabilities and make sure that we can harmonize.
Ralph,
I see you, Mark.
Hello. Very good to hear you describing all these. As we have discussed in the past, immersion capability is enabling a lot of new things. It's a big degree of freedom in position and in placing components. Maybe you can invite the server community to start thinking totally out of the box. If we keep doing the way server designs are being done, the value that we can get out of it will be whatever incremental benefit is. But if we invite people to pack things in a denser way, not worry about the type of problems that we have with air cooling or even cold plate models, immersion opens up new avenues. Maybe through that, we can create some excitement.
I totally agree, and you hit the nail on the head, right? So this is where the design guidelines for immersion optimized IT equipment, that's one of the work streams that Austin Hypes is overseeing. That's really where these kind of elements can really be of value and come in. What are the potential avenues that I would really like to explore? But yeah, that's part of the conversations I'm going to be looking forward to. Is also potentially involve somebody from the server project as a co-chair for the ITE committee within the immersion project. Austin is currently the sole chair for it, and we do mandate dual lead roles for all these work efforts for continuity purposes. And this is something where, we're going to be looking forward to explore ways to increase the collaboration with immersion and server.
Yeah, right. The simple requirement of front to back airflow, position of DIMMs or CPUs in a particular way, I/O cards being in a particular way, a lot of these things will go away. So mechanical and fit will be so different. So maybe as part of a brainstorming at the beginning, you can invite people to say, okay, if I didn't have these constraints, what magic could I do that's enabled by immersion cooling? That might create some good excitement.
Yeah, and is this now going to get mainstream enough that we define an MHS form factor that's more for liquid or not? That's something I can't answer. We'll have to see as we go forward what kind of responses we get.
And that may be a bridge too far to start with, right? Currently, the need is in very specific work streams that are assessing how do we deal with reliability assessments, right? That's one of the key elements that also feeds into warranty discussions. That's where Samantha Yates from Intel is doing fantastic work with progressing that work, but that's also where we need some of the capabilities that are in this community, as well as the design optimization for IT equipment. So the IT equipment as a whole, that ecosystem, that's where we're really interested in looking further. What are how can we strengthen some of our community efforts, where we currently have a massive participation of fluid manufacturers. But with all due respect, we really appreciate those type of contributions and that type of interest. But it is not as valuable as having the IT IT ecosystem involved, which is the server project mostly, right? This is where a lot of the design work happens. And how can we jointly optimize some elements for immersion cooling? And that's CMAC, that is also includes the type of discussions that you just described as well. So I think that's where the short-term goals could really benefit. And yes, a spin out of that on the longer term might be the actual dedicated immersion specs, but it might be a bridge too far for today for today's challenges.
Yeah, well, I'd say it's about figuring out where the interest is, and you know, if there's other companies out there who are willing to have volunteers step up and push that forward.
Yeah,
being a volunteer organization, nothing really happens unless you have companies ready to stand behind it, right?
Correct. And that's where we need help. One of the things we do now is that most of the server manufacturers are looking at immersion. A lot of them are taking their own approaches to immersion cooling. And these are things that we do want to enable, but also facilitate in terms of creating reference materials that everybody can use. And that's what OCP is all about, right?
Yep. Well, thank you very much for the conversation. We are quite a bit over, so go ahead and wrap up the call. Thank everyone for joining this month, and we'll talk to everyone next month.
All right, awesome. And John, the meeting for Thursday, we might want to push that out due to availability of some folks, but we'll see how the correspondence goes with that.
Yeah, sounds like it might. All right.
All right. Thanks.